Welcome to Unit 4, and in Unit 4 we'll be looking at electrochemistry, and this is session 1. We'll be looking at Introduction to Electrochemistry. By the end of this session, you should be able to define electrochemistry, define electrochemical cell, distinguish between galvanic cells and electrolytic cells. Basically, let's try to get some concepts in understanding electrochemistry. When we talk about electrochemistry, it is the area of chemistry concerned with the interconvention of chemical and electrical energy. When we talk about electrochemistry, it is about a science that unites electricity and chemistry together. So basically, we say that it is a transfer of, or it is a study of the transfer of electrons. So if a chemical reaction is driven by an external applied voltage, as in electrolysis, or if a voltage is created by a chemical reaction as in a battery, it is an electrochemical cell. So there are two components of electrochemistry where we use a spontaneous reaction to generate electricity, or using electricity to cause a spontaneous reaction to occur. These are the two components of electrochemistry. When we talk about electrochemical cell, basically it is a device for interconverting chemical and electrical energy. Electrochemical cells have two basic types. We have the galvanic cells, which are also called the voltage cells, and what we call the electrolytic cells. The galvanic or voltage cell is basically a device in which a spontaneous redox reaction is used to produce electrical energy or current. In principle, the energy released in any spontaneous reaction can be directly harnessed to perform electrical work. So like I said earlier on, when we talk about galvanic cell or voltage cells, they are used to generate electricity as a result of a spontaneous reaction that is taking place. So that is basically what the voltage or galvanic cells does. So this is simply a voltage or a typical voltage cell. So we have the zinc anode. So basically this is a representation of the reaction between zinc and that of copper. So we have the zinc anode, which is the electrode. We have the switch, we have the voltmeter. We also have the copper anode, cathode, and then we have the solutions. So in this particular reaction, you realize that zinc is undergoing oxidation whilst copper is undergoing reduction. And remember, oxidation occurs at the anode and reduction occurs at the cathode. However, you also have to take note that electrons always flow from the anode to the cathode. Electrons flow from the anode to the cathode. However, this diagram would have been incomplete if we do not have the salt bridge. So the salt bridge is composed of a chemical substance that is unreactive to any of these solutions. So in this case, we're using sodium nitrate. So the negative or the anions from the salt bridge moves towards the anode and the cations move towards the cathode. Now, also note that we have our voltmeter here that we can use to measure the voltage that is flowing across the two components. So the voltmeter here is what we use to determine the voltage of the reaction. Now in the cell, electrons leave the anode and flow through the wire to the cathode. So as the electrons leave the anode, the cations dissolve into the solution in the anode compartment. So if the anode dissolve, or the anode of the zinc electrode dissolves, basically what happens? Then the zinc will begin to decrease in mass. So as they get dissolved, they get deposited on the copper electrode surface, and because of that, the copper cathode increases in size. So basically, the anode always decreases in size and the cathode increases in size. So basically, we have what we call the cell notation. So for the cell notation, we write it as the anode first, then we bring a single stroke which separates the faces of the two components. So you realize that this is a solid phase and this is an aqueous phase. So the single line differentiates the faces, and then the double one indicates the salt bridge, or the double line indicates the two, or it separates the two reactions together, the two half reactions. So this is just separating the phases, and this is separating the two half reactions. So this is basically the anode, which is the zinc electrode, and then we have the aqueous solution, which is a zinc sulfate solution in this case. We also have the cathode electrode, and then the cathode electrolyte, which is a solution, and we also have the cathode electrode, which is the metal we are using. So remember, oxidation occurs at the anode and reduction occurs at the cathode. Remember that the two double lines indicate a salt bridge, or it separates the two half reactions, and the single lines differentiate the phases of the reaction. So in this particular session, you've been able to look at what electrochemistry is, electrochemical cell, oxidation reduction, and then the galvanic cell. So as a session review, define the following terms: electrochemistry, electrochemical cell, oxidation, reduction, and then try as much as possible to describe the galvanic cell. Thank you, and I hope to see you in the next session.